Hello, everyone. Today I'm going to talk a lot about Xcode. It might sound like I hate Xcode. I don't. I like it. We fight a lot Xcode, and I want to tell you everything that we learn so that you don't make the same mistakes that we see companies doing. Let's start. But before we do, my name is Pedro. I'm based in Berlin, although I'm originally from Spain. I like building open source, and I like building tools for developers. I'm a developer that whenever I have an itch, something that doesn't work in the way my mental models work, I go and fix it. That's how Tuist started. And I'm the creator of Tuist, and now I'm co-founder and CEO of Tuist GmbH. GmbH is a limited company, and we are working on making the whole project financially sustainable so that we can continue to support companies with the tool. Tuist is a tool that helps you with project management. What that means in plain words, because you might wonder, I don't need any tool to manage my project because I'm the one managing it. You might need, but we basically fight Xcode intricacies so that you don't have to. So that's the summary of what we do. To my parents, I say that we help developers stay productive, and they understand what we do. So that's what Tuist is, and everything that I'm going to share with you is things that we've learned through the process of building Tuist for the past 7 years. Before we understand Xcode and the challenges, I think it's important to understand a few things. When we think about development, I like to think about development in terms of layers. There are a set of concepts and elements that define a language that everyone works with. So when I say target, when I say scheme, build settings, sweep macros, no one is looking at me like, what are you talking about? Everyone knows what it is. That is very important. There are some concepts that are specific to Xcode ecosystem. There are others that are specific to other ecosystems. There are others that are the same, but they change names. For example, I think Android uses flavors, Xcode uses configs, there are build settings. So that is very important. And on top of that, we need a way to define the language. We need a project. That is the representation of the concept. It's like if you take something that is very abstract and you materialize it. So we have Xcode projects and we have workspaces. What I say that is actually the API to describe those concepts that you're familiar with. Then you have a concept, you have a project, you need a tool to work with it. You need a build system. The build system is the tool that you need to compile the project. There are two build systems. There's the one that you directly interact with through the terminal. It's called Xcode Build, and a bunch of other tools that come with it. And there is Xcode, which is the same, but through a visual interface. So instead of going through the terminal, you go through a visual interface that is much better ergonomics for developers. So from the bottom concepts, projects, build system, and then we have the editor at the top. So many years ago, building an app was super simple. There was only one platform, there was only one project, one target. Xcode was simple. I think there was something before Xcode, but I don't remember the name. But it was a different time. So projects didn't have much complexity. But that was maybe 20 years ago. A lot of things have changed, and you know. So what changed? A lot of things. Like these days, it's very common to have a workspace, maybe with multiple projects, because we might need multiple targets, not just to support multiple platforms, but also to share sweep files across targets. Also multiple products, apps, extensions, targets per project, external dependencies. So with all of that, something that was simple becomes more complex. And Xcode, everything that you've seen in those layers has to evolve. They need to introduce new concepts. So if Apple suddenly says sweep packages, developers say, I want Xcode to support sweep packages. If Apple says sweep macros, which is something that they introduce in the build system, is a concept, sweep macro, then you evolve the build system to support it, and you need the editor to kind of follow that. So things are moving fast, and Apple has to move the tools at the same pace as they do with those concepts. And sometimes they don't do it that well. Xcode is a 20-year-old editor, and it did as best as it could, but unfortunately, there are so many things that are so painful to work with, and I'm gonna spoil you what those are. There are way more, but I would need the whole night to talk about those, so I'm gonna stay very concise. And those are the, but before I talk about those, there's one important thing that it's key in understanding why Xcode is designed the way it is, and it's the fact that Apple is always optimizing for convenience. So what does it mean? So they want developers to spend not a lot of time configuring things, and they want people to be able to create an app, be productive right away, and ideally be convenient for as long as possible in the journey of you building the app. And they achieve that with a lot of defaults, and they also achieve that with a lot of implicitness. The problem with implicitness is that when you scale, you actually need the opposite. You need explicitness, because when things are explicit, you can analyze them, and you can optimize them. So what works great at small scale is actually a terrible idea at large scale. And a lot of what Tuist does is making implicit things explicit. Apple keeps investing on the implicitness because I think they continue optimizing on the small to medium apps, which are the ones that bring money. Like Spotify, Netflix, they have their apps on the store, they don't bring money to Apple. So why would you invest in this when who is bringing the money is that? So that is I don't know how Apple makes decisions internally, but that's my assumption based on everything that I've seen. I think they really optimize for the small to medium app. So yeah, let's talk about the challenges. I'm gonna go through them. That's the list. I included 7. Maybe later in the networking part of the session, I can share more with you. And some of them might sound like I've never seen that, and I don't think that's actually true. I'm gonna do a demo to show you that it's actually true. For some of them, not for every one of them in the list, but for some you will see that actually what I'm telling is actually true. When you take some of the Xcode features and then you use them at a scale, they actually behave so much different to what most people are talking about. And this is important, especially if you think about my app eventually will be large, or there will be many people contributing to it. So let's start from the first one, a maintainable dependency graphs. So you have multiple targets in your app, and then you start adding dependencies here and there. One second. So you start like adding targets here and there, libraries, frameworks, dynamics, static, and you probably know that whenever you add something to your graph, it is not that you just add the element, it's that thing that you're adding has some cascading effects. For example, you have a graph with 3 targets and suddenly you add one dynamic framework very far in your graph because that framework is dynamic and it needs to be copied inside the app. So the app has to have a copy build phase that takes the framework, dynamic framework, and copies that in the right directory. So that is easy when you have a few targets. When you have 10, 20, 100, things start to get very complicated. It is impossible to visualize the graph. Like if you open the Xcode project, can you see what depends on what easily? You can't. There's no way you say, can you tell me what are my dependencies? Yeah, build phases might show something, but there is also something called implicit dependencies, which actually are another nightmare in Xcode, and I'm going to talk about those later. So the graph is implicitly codified in the project. You don't see it, you cannot visualize it, and if you don't visualize it, it's hard to know how to optimize it, and that is a problem. So things that you can do to overcome that, I'm gonna talk about Tuist because that's how I solved that, but there are also other tools. So for example, you can make the whole thing more explicit through build systems that are more explicit and more declarative. A good example of that is the Swift Package Manager, but you can also use Bezo. Bezo gives you an interface you see in every moment. So each of the targets you can have tools for like visualizing the dependency graph. So those are options that you can explore. And one advice is try to keep graphs as simple and shallow as possible. Don't get crazy like the NPM ecosystem that every file, like they have packages that contain only one file, but also not have too few because that also means the incremental builds won't be as effective as they could be. Let's talk about implicit dependencies, because I mentioned that in the graph. There are two types of implicit dependencies. The first one is the one that you see in the scheme option. It's called find implicit dependencies. Have you seen that in schemes? You say, hey, Xcode, like find what you think depends on what, and then build it in the right order, so that hopefully my build will succeed. What that means for me is my graph might be invalid. Do your best to fix it at build time. And that is bad. The second type of implicitness is the one that happens to the build products directory. So you're going to see that later. You have a target A, target B, and target C. A depends on B, B depends on C, but A hasn't declared a dependency with C. But because C builds first and its output in the same directory where everything is output, A is able to import C even if it hasn't declared the dependency. So that type of implicitness through the derived data directory is very bad. Because maybe everything works fine, eventually like someone changes something and everything breaks, and then your developers spend 2 days trying to understand where the dependency is missing. A lot of headaches, so that's what happens with this type of implicitness. So my advice is always disable that find implicit dependencies from the scheme, and Tuist has an option, it's called force explicit dependencies. I'm going to show you later. That basically says we are trying to mark this Xcode behavior as an anti-pattern, like don't use it. Everything needs to be explicit. If you try to import, if A tries to import C and it hasn't declared the dependency, you don't compile. That's what I would expect from a build system. Don't try to be magic about something that is not well defined from the beginning. The other one that we see a lot is this also if UI previews don't work. This is kind of funny that Apple develops a feature and then for many developers it doesn't work. And I've heard like some tips for how to solve it. I'm going to share some. There was one developer saying that if you use scripts in your targets, you need to make sure that you declare the inputs and the outputs of the scripts. If you don't do it well, then you might see like, the previews don't work. They also say that dynamic products are better than static. So consider that when it comes to trying to make Swift UI previews work. And something that I've seen some companies doing, which I think is cool, is having example apps. So if you organize your app in feature modules, have an extra module associated to each of them that contains an example app. Because maybe that one compiles very fast and is more reliable. I kind of imagine why it doesn't work. In the end, you have to think about what Apple has to do is they actually launch a simulator. So when you see the preview, there's a simulator there. So the simulator is loading some piece of code, and the piece of code is depending on a bunch of other things, some of them transitively, some of them implicit. So the editor has to talk to the build system and say, hey, I want to show the Swift UI preview. There's a lot of implicitness here. Do your best, and hopefully give me something that works. So that is a lot of complexity. That is actually a very impossible task for Apple because of the implicitness. So that implicitness that was very cool at a very small scale, it was very convenient. When you grow, it's actually going against Apple in making their tools reliable. And so yeah, that's, if you are running into this issue, remember this, I think is very important. Try to keep things as explicit as possible, always, because that will make things very predictable. The other thing that we've seen is a slow compilation of Swift macros. This is because they have to, the macros usually use the Swift syntax set of packages that are necessary for getting an AST of your Swift code. And when you add the dependencies, suddenly you have, I don't know, additional 10 packages that you need to compile. And it can add a lot of compilation time to clean build. This is something that a lot of people are complaining about, so I wouldn't be surprised if Apple provides a solution there. I think what they will most likely provide is something similar to Foundation, like some kind of framework that is shipped in the toolchain and then you link against it and you don't have to be compiling it yourself. So things that you can do is wait for Apple. So many of these things, one of the answers could be like wait for Apple, file radars and put pressure. I think Apple is very pressured with this one, so I'm sure they will do something, otherwise I don't think people will continue using macros. The second advice that I give is avoid this macro all the things that we're seeing, they have a cost. And there is, with every feature, you always think about the value that it brings, but also the cost. And this one has a huge cost. Your code suddenly is being generated. If everything in your code base is being generated, you have a stronger dependency with a build system that is not designed for scale. So it might actually get in your way of making your team more productive. I was learning recently Elixir, and Elixir is a very macro-oriented programming language, and I read a book about macros, and it was funny because the first thing that they recommend about macros is to not use macros, because macros have a lot of caveats that you need to be aware of. So when it comes to introducing macros, be mindful about that, because you might end up adding a lot of, bringing some headaches to your team. The other one that I find, and that we've seen companies finding very annoying, is everything that has to do with optimization. So locally, it should be fine, like Xcode has these incremental builds. So if you only change one file, in theory, you should only have to compile that one, and the other files that depend on this one. But because of the implicitness, again, that incremental build might end up being not as reliable as you think it is. Or what I've seen many developers doing is when they see an error in Xcode, they try a few things, and if none of them work, the first thing that they do is delete derived data or clean. So when you clean derived data, you're doing a clean build, and depending on how big the code base is, it might take a lot of time. Another source of slowness is also running tests. So if on CI you're running all the tests all the time, if eventually you have a large test suite, it might end up taking 20 minutes. And that's a lot of time. So what we are doing in Tuist and also more advanced build systems like Bazel is trying to be more selective about what you build and about what you test. So if you push your changes to CI, we can see what you change. And based on your changes, we determine what needs to be tested and what needs to be built. So you save a lot of time. And in the case of CI, money. And in the case of local, you make developers productive. They will be happier working with the project. This is another one that I don't see many people talking about it. I think there should be more people talking about it. Xcode is like Xcode integrating with the Swift Package Manager. I don't think is the best developer experience. You have little control over the graph. Like suddenly you go from your Xcode that used to be something static, something that you open, and something that is ready to compile, to something that you now open and it's not ready to compile. It's like loading, resolving graphs, doing a bunch of other things. And it's fine if you have a few packages, but I've seen organizations moving all their project to packages. So suddenly, all my project, 100 modules are 100 packages or 100 products inside packages. And then, I'm going to show you what I mean by slowness, because I can just say it. I want you to see what it means. It can be very slow. And one thing that I keep telling people, and this is very important, is Apple designed the Swift Package Manager to be a package manager for Swift. Developers asked Apple for the Swift Package Manager to be something else. First thing that they asked was, I want the Swift packages to be able to contain Objective-C code. And because of that, Apple had to do a lot of hacks internally to make Objective-C work. We had to learn about those because we do some integration with with Tuist. And those things are not great. The second thing that they did is, because people don't like these Git conflicts in Xcode projects, they started to use the Swift Package Manager as a project manager. So you take a tool that you've designed for dependency management, therefore the decisions that you make are for dependency management, and then your community takes the tool and uses that for something else. So now they are juggling this Xcode build system, Swift Package Manager build system. I want things to be fast, and because of the design decisions that they made, it's going to be super challenging for Apple to make the Swift Package Manager work for a large scale. Tools like Bazel are more suitable for this thing. And the first thing that they will have to change if they ever want to turn that into a project manager is probably not using Swift as an interface. Because every time you change something, they have to recompile those packages of Swift. The whole understanding of the graph is very slow, and the last thing that you want from a build system is slowness. Let's talk about numbers. So this is from a blog post that Bumble, a company, wrote about. They did an analysis of Bazel, Swift Package Manager, and Tuist. Spoil, they ended up choosing Tuist. And what they did was, they compared the Swift Package Manager with Xcode Proj to see different actions that developers usually do with their projects, how much they take with the Xcode approach, how much they take with the Swift Package Manager. And you can tell that, for example, things like renaming a file, that in Xcode approach they take 0 seconds, suddenly with the Swift Package Manager they take 15 seconds. So you rename a file and for 15 seconds, there's something happening in the background and you're unable to do anything with the project. Or your clean build can go from 6.3 minutes to 16, more than double. It's a lot of time. These are numbers, real numbers, collected by a company. So it's actually not great. So before you consider modularizing your code base with Swift Package Manager, either wait for Apple to fix it or consider anything else. I think it will be hard for them to fix it. They will have to make a lot of changes and be super strategic about where they want to take the Swift Package Manager. And if it should just be a Swift Package Manager, I think they should actually merge their build system and the Swift Package Manager, merge them together, and rethink some of the things that they put into the tools. So yeah, my advice would be that you only use it for integrating external dependencies, or alternatively you use Tuist. What Tuist does is it takes all those packages. I like to say that what Tuist does is if you took Carthage, CocoaPods, and Swift Package Manager and they three had a baby, that's what Tuist does. So we take Swift Package Manager as a tool for resolving dependencies, and we have a new command called Tuist install. That is the same as CocoaPod install. You take all the sources, you pull them locally. The second thing that it does is when it integrates them into your project, we use Xcode projects and Xcode targets, same as CocoaPods. And the last thing that we do is we have this command called cache that is able to convert everything into binaries. And when you convert everything into binaries, it's the same as Carthage. So imagine the three things together, and I think the experience is much better. You have one command installed, you pull the dependencies, you open the project, and then when you open it, it's just a standard Xcode project. It's ready to compile, you can add a file, it takes no time. And the last thing that we've seen Apple doing, and we've seen also a lot of people confused about this, is this whole mergeable libraries. So you probably know that dynamic frameworks, they might impact negatively your startup time, if you have many of those. And so they recommend using static frameworks or static library when it comes to release, because you don't want the app to take a lot of time to launch. But the problem with the static frameworks is that they take a lot of time to compile. So ideally, in your release version of the app, you just ship with everything static. Locally in development, you want fast compilation, so you want everything to be dynamic. The problem with changing between dynamic and static is that because the graph is not very manageable, as I said earlier, you have to either use a tool like Bazel or Tuist, or you cannot do it. If your graph is very complex, like imagine going target by target, changing the product type to static or to dynamic, and you have hundreds of them. You can maybe automate something there, but it's not the best experience possible. So Apple wanted to solve it, and once again they decided to put more magic to solve it, and they said, well, now we have this feature called Mergeable Libraries, which basically means at build time, we are gonna do our best to provide you with this switching between dynamic and static, and hopefully what you will get as an output is something that you expect. But that makes things even more unpredictable. So on top of all this, I need to find implicit dependencies. I need to decide if this needs to be static or dynamic. Like all this logic that the build system has to kind of guess at build time, it starts to make things very unpredictable and also very hard to optimize. What we do is, in Tuist, is when you describe the project, it's very easy to say, I want everything to be static and I want everything to be dynamic. The project generates, Tuist generates the project, and that's it. It's super easy to change. And let me do a demo of a bunch of things that I think you will like, and they demonstrate some of the things that I talk about. Let's see if I can. So the first thing that I'm going to show is, I want to show you the Tuist workflow, and then from there I'm going to comment some of those challenges and how Tuist solves them. So one of the first things that we did in Tuist was we tried to optimize the projects. So we optimize them in two ways. The first one is we can you can select the targets that you plan to focus on, and then the targets that are not necessary to work on that are removed from the project. Because the smaller the project is, the faster Xcode is. So the way you use that feature is, I'm going to use the Tuist project itself. We use Tuist with Tuist. We do dog fooding. So I'm going to run Tuist against the Tuist project. So let's say I want to focus on the target, it's called Tuist support, so I do Tuist generate. I'm going to make it a bit bigger, Tuist support. And then I'm going to use this flag called no binary cache. For now, I'm going to show you later what that is. So it takes the definition of the project, which is in files called project.swift. It's the same as package.swift, but with the language of Xcode. You have schemes, you have build settings, you have targets, dependencies. So when you create the project, you have Tuist, the project itself. You have all the dependencies that Tuist depends on. Those are Swift packages, but they don't look like Swift packages. They are. You probably recognize some of them. What we do is converting them into Xcode projects. That way, when I open the project, everything is ready to compile. If I add a file, it's instant. And from the Tuist targets, you see that there are only two. Because I explicitly said I want to focus on Tuist support. I don't care about the others. So we take that one, we take the dependencies, and we remove everything else. And project description is there because Tuist support depends on project description. So fewer things, faster Xcode. That's the idea. Still, I would like to, in my mind, it didn't make sense that we had to compile those external dependencies. That was one of the good things about Carthage. That's code that doesn't change. You just pull it from the repository. You just want to use them as binaries. So what Tuist does is we have this feature called cache that basically says we have one command called cache, and it takes everything, persists everything in your file system as binaries, and then you run generate, and it's going to try to reuse as many binaries as possible. So if we do the same command as I did before, by default, it tries to use the cache, and if we look at the logs, it's telling me that it's using binaries for all these dependencies. So let's look at the project. Now, we don't see any project here, any dependencies here, no Xcode projects, because now there are binaries. And if we look at the cache folder, they are all Xe frameworks. So if I clean, and I build, I only have to build the target that I'm working on. So imagine large organizations where they have multiple frameworks, multiple targets. Most of the time you are working on your target. So you don't want to be compiling everything else all the time. This saves you a lot of time. And the same that you see here, it happens on CI. So we only build what needs to be built. And also macros. I don't know if you noticed, but we have this mockable is a macro. So the macro is actually an executable. So we take the executable, we put it inside the Xe framework, and we set up the project so that it can use the macro from there. So you don't have to compile macros, you don't have to compile your dependencies, everything is fast. And I can try with another target. For example, there's another one called Tuist Kit. So I'm gonna do the same, but Tuist Kit. I can pass multiple of them. For example, Tuist generator. And there you go. So now you see more elements here. That's because it's also able to cache my targets. So not only the external ones, but also mine. So now we have Tuist Kit and we have Tuist generator. So I only work on those. If I change anything in Tuist generator or any other target, we are going to recognize that you changed something, and therefore we cannot use binary. So we are going to take the sources. And this is really a time saver. So let me check what was the next thing to show. Yeah, macro caching. Yeah, let's talk about implicit dependencies. We have this project that has an implicit dependency. And I said at the beginning that one thing that is very annoying about Xcode is that you cannot see the graph. And this is something that Tuist allows you to do. So if we are in this project and we say Tuist graph, it creates this image where you can see the graph of your project. This is very convenient here because the project is small, but I need to show you something, which is very funny when you see it for the first time. But let's try to do the same thing with the Tuist project. So if I do Tuist graph, this is the Tuist project. Can you see the macro there? Can you find the macro, where the macros are? Any guesses? I said before that it's many packages. It's one thing that you add and suddenly there are many packages in your graph that you didn't want to have. So if you look at the right side, there's this red thing hanging there at the bottom. That is a macro. That is a macro plus everything that the macro needs to compile. So that adds a lot of compilation time. And everything else are external dependencies and targets of your app. We are doing something to make the whole thing more manageable. Like images are not really, we reach a point where like you cannot really do much with this. You need to follow the lines. You can still export this in a format that you can then use with other tools that are more interactive and allow you to do filtering. But going back to the explicit dependencies, we have this graph that says framework C depends on B, app depends on B, and the framework A depends on B. No, actually, doesn't depend on B. But some developer decided that they want framework A to import something from B, right? Like it happens, you are just writing code and you, from framework A, you say, A, import framework B. So let's see what happens in Xcode. I generate the project. Actually, not this one. This is Tuist. Let's go back to this. And then you see that framework A is importing B. That's not defined as such. So in theory, Xcode should tell me, don't try to do that. But Xcode tries to do its best to make every developer happy. So if you compile A, it compiles. I clean, I try again just in case you didn't see it. Actually, this is like the most things. I think if you compile B first actually, or yeah, if you compile B first, and then you compile A, the app, sorry, it actually compiles. So depending on which order the build system decides to build things, as soon as that framework B is in the derived data directory, then it's visible to anything. So what Apple should have done this, instead of treating this derived data directory as something flat, they should have created some kind of hierarchy there so that to make frameworks visible to only the targets that should depend on them. So this is not ideal. So what we did was we had this option here in Tuist. Config.swift is an interface for you to configure the tool. You can say, hey, enforce everything to be explicit. So I do Tuist generate. Another tool will make some extra configuration for you so that if you try to do something implicit, like it doesn't allow you to compile. So if I clean, I can try to build B first, as I did before. That should compile first, fine. And if I do app now and I try to build, it doesn't allow me to do that. So these are the things that I think are important at the scale. That when I said before that they should evolve the build system to prevent these things from any advanced build systems, this is like things that you should never do, but they allow it because of convenience for developers. So that's an example of another thing that we do. And last, I'm going to show you the difference between integrating dependencies with Swift packages, like Xcode does by default, and how Tuist does it. So I'm going to use this tool that uses composable architecture. So I'm going to go to composable architecture project. I'm going to open it. So I clean, and then you see that if I try to compile Xcode, is actually in this case it was everything resolved, but it usually takes some time to resolve dependencies. If you delete derived data, you might end up deleting the data of like the dependencies that have been resolved, and that takes a lot of time. Just compiling, dependencies are there, it's fine. We don't have a lot. Well, actually, I think it's a lot for a package, but anyways, so those are all composable architecture dependencies. The thing is they're compiling, it takes some time. Mostly external dependencies. I'm not compiling my code. The app is very simple, it's a few lines of code. Let me compare that with the equivalent on Tuist. So I go here, I do Tuist generate. I'm going to use caching. I cached everything before the talk, so everything is compiled as an Xc framework. So you do Tuist generate, then you get the same project, but everything as an Xc framework. If I compile, it's seconds. I clean, I compile, it's seconds. So this is a small example. Like imagine if it's a large app, it's a lot of time. So yeah, we are obsessed with making developers productive. We are trying to prevent developers from running into these issues that are actually a nightmare at a scale. And with that, I think that's all I wanted to share. Yeah, no, actually, no. I wanted to share something more. Some hot takes of the talk. I think broadly used doesn't necessarily mean they're suitable for a scale. A lot of the conversations that you see public are about how to use them in like small apps or maybe for like writing some blog posts. I think you need to really, if your organization is large, like talk to other organizations that are like trying to do, because one thing is using that at a small scale, another story is when you use it at large scale, and that is important to keep in mind. As I said, explicitness, and explicitness. And if Xcode allows you to do implicitness, actually don't use it. That's our advice. The more explicit, the more you can optimize, and the more you can understand your project. When you bring that implicitness at build time, then things become unpredictable, and for you and for Apple, for their tooling. Like you saw with Swift UI previews, like it doesn't work. Why? Because you are using these features that Apple gave you years ago, and you think they are cool, and they break your project. Swift Package Manager is a package manager, but it's not, right now in its current state, is not the best solution for project management at scale. And yeah, using Xcode at scale is definitely feasible with little cost. I talked about Bazel several times. We started building Tuist because Bazel has a huge cost for organizations, and we could prove through Tuist that it doesn't necessarily to be costly for you. And if you want to use it, you can go to the website, you can install the tool, and yeah, either create a project or migrate an existing one. Yeah, and that was it. Thanks.
Thank you very much. Any question? Only one question? You sure? Because if there is more than one hand, we take pizza first and then we answer questions. Only one?
2 hands, pizza first.
Yeah, pizza first, and just in case, because I don't trust you guys. Let's take the pizza and then we just come back and answer the questions. Camera is good? Alright.
I already talked to you, so.
Yeah,
I guess
for everyone, like maybe.
Okay. I was wondering. Oh, feels weird. I was wondering how. Wait, what did I ask again?
I forgot to.
That's what you should read.
What was it? Well, one was how you would edit the packages. If you have a workflow where you would basically want to edit your Swift packages, for example, or external dependencies in a workspace, how would you do that?
The workflow is the same as with Swift Package Manager as an integration tool. Like you can have that code locally, you can adjust your project to point to that one, and then we just link it.
I feel like I need to say more.
More pizza.
No, I have. So I was wondering, when you use Swift Package Manager, right? And you have the source code of all the packages there. If you get a crash or an error, let's say a crash inside the package, it will literally show you the line which line in the code caused that crash because you have the source code. But if you do a binary like you showed for the packages, then when it crashed, it wouldn't show me, right?
We include the symbols inside, so you would see where it's actually crashing. You don't see the. I haven't tried to see exactly what you would see, but I think you would see something. No, I don't know if it's the interface or maybe a bit of implementation, but we include the symbols in theory Xcode to provide a good experience with this debugging scenario.
Right. And the symbols are only included when you're doing like a dev configuration, but when you build for production, you don't include the symbols?
For production, that's actually a good point because they're included in the Xcode frameworks. The Xcode frameworks are linked from your app, and then we will need to provide a workflow that extracts the symbols and provides them to you in some directory so that you can upload them to whatever error reporting platform you're using. For now caching, we designed it to be for development, and we plan to extend that for release in the future. If we extend it for release, this is a feature that we would need, like basically Tuist release the app for me and also export the symbols from all these binaries because I need to upload them somewhere.
Yeah. I guess I can ask more. So let's say you're using Xcode Cloud. Would you recommend using Xcode Cloud with Tuist? Basically just having run the CLI?
Yeah, Xcode Cloud has this, you can specify scripts that are run in some particular moments, and there's this one that is run after cloning a repo. So you can use that for installing Tuist, generating the project, and after that Xcode, all Xcode Cloud needs is an Xcode project or an Xcode workspace, so it doesn't need to know who generated the project or where the project came from. And it's the same for any CI environment. You run something before doing whatever you want to do with the project. Same as can I use Fastlane with the project. Of course, like that's one of the principles that we follow. Whatever we generate is something very standard. So if you were using Fastlane before, you can use Fastlane with that project. If you are using your bash scripts against the Xcode project through Xcode build, that will continue to work. Nothing changes there. The only thing that changes is that there's one step before that you have to run on CI, and locally your developers need to get familiar with, instead of double clicking on the Xcode project, they just run the command and it opens. And we're doing our best to make that as fast as possible. It shouldn't take more than a few seconds.
Yeah. Is there like a plugin or something that you could have that it looks like a project icon and I can click on it and it runs the Tuist command and it opens the project for me? So it's all fancy and
I wish there was something like that. But yeah, I don't think it exists. If you know, please tell me. Yeah.
That's it.
And I knew it. I'm just wondering, is there any tips for, like, now my company's project is so complicated, it's like a trash. So it's so complicated, its dependencies are like, as you mentioned, after clean, it takes so long time to build. So is there any tips for existing project to apply the Tuist? I mean, how could I use the Tuist well in the existing complicated project? Is there any tips?
So all the implicitness that I talked a lot about is bad for anyone, including Apple. So even the features that they have to optimize your builds, they don't work reliably if your project is complex. But your project is complex because they allow that complexity to exist in the first place. Kind of like a chicken and egg problem here. So what you need to start doing is cleaning that project up and like adding some consistency. Ways of doing that is, first, your build settings need to be very consistent. So instead of using the ones that Xcode generates by default when you create a new target, extract that into an xconfig file and reuse the config file across all the targets. If someone modifies a build setting in the target, don't allow that. Add some linting, fail, everything needs to be in an xconfig file. When everything is consistent across all the targets, like removing inconsistencies will make the build system to be way more predictable. For context, a lot of people that migrated to Tuist, they migrated their projects. When they were done, they came to us and they said, my build is faster. And we were like, we haven't done anything to make your build faster. It's a side effect of having a cleaner project. So it's called xconfigs first, then explicitness in the graph. So I wouldn't use that in find implicit dependencies. I would disable it. I would weaken so that feature that you saw in Tuist, we do it automatically for you, but it's something that you can also implement yourself. We kind of, in the build phase, we output the files in a different directory, and through build settings we control what targets can see. That's something that you could also do. It's a bit of work if you don't use a tool like Tuist, but if you do that, then the whole graph is more explicit. And when the build system tries to parallelize that, because it can have this picture of what depends on what, then it's able to parallelize as much as possible. Whereas if there are many things that are implicitly resolved, suddenly I want to build something, I don't know how to optimize, and then the build is slower than actually it could be. So xconfigs, disable the high implicit dependencies, and try to implement that enforcement of explicit dependencies. I think with all these things, it will be faster. The other thing is also the dependency graph, the way you organize the modules matters a lot. So there will be this tension between, on one side, like it has to represent your company structure. That I think there's a principle around that, like in the end the software will model the organization in a way. And on the other side, you want to make sure that also the compilations are fast. So you have very fast laptops. They should be able to parallelize as much as possible, but it really depends on how you organize the graph. So when you design your modules, try to avoid very deep modules that are huge and that are changed all the time. Because every time you change the deep modules that are large, you're invalidating everything that depends on that thing. So you should have fewer modules, like smaller modules that are basically more, the scope is more reduced. For example, instead of having core that contains networking utilities, I don't know, design system, a bunch of other tools, treat those as independent pieces and like create the modules. The problem is that when you start creating modules, you need to manage them. And then you end up in this problem that I was describing at the beginning where the graph is unmanageable. So even though you can do things yourself in Xcode, eventually you will realize that managing that whole thing yourself is a pain in the ass, but you need to do it if you want to keep things optimal. So a lot of a chicken and egg thing. So I would suggest Tuist, but you can do some low-hanging fruits yourself.
Any other questions? No? Yep.
First of all, I'm really big fan of your project. Thank you for the great product. And I'm just always curious about the motivation of the open source project. So can you share any episode, which motivated you to start this project?
The motivation was, I was working in a code base that was modular, and we started to modularize it to benefit from like parallelizing of builds and a bunch of other things. And we were facing constant, like someone adds a target and then it fails somewhere else. Everything works locally, I push, and then it fails on CI. Flakiness, you put something, half an hour, you get an error, you fix, you push, you wait. Half an hour, conflict, then fix the conflict, then push, then wait, then 1.5 hours, and you need to go for a coffee. It's very unproductive. So I started building the tool, and when you think about that stack that I shared initially, you need to see how exactly you can do that. There are things that you cannot change. Like changing Xcode is a bad idea, super bad idea. Apple wants that to be the default, and that's clear. Like you're not gonna change Xcode. I've seen some people trying to build editors. That's a huge effort. We didn't want to do that. Build system. The editor and the build systems are so coupled together that if you try to replace it, which is what Bazel does, you are hacking something into Xcode. So you can make it work, but with a huge maintenance. That's the main issue with Bazel. You put it in your project, and it might break with new Xcode versions. We are using standard Xcode projects, nothing breaks. And the only layer that was really missing was the Xcode project itself. So ideally, Apple would allow a lot of extensibility there, but they don't. If you think about other build systems like Gradle, Bazel, they're all extensible. They have concepts like I bring a plugin and the plugin extends my build. I have a build task that depends on another build task. Everything is very deterministic. You can visualize things, you can extend it. Xcode doesn't allow that. You can have a build phase that is script, and that's it. So because there wasn't extensibility, we did project generation. And we were not the only ones doing project generation at the time. Do you know who else was doing project generation when we started? Can you think of a tool that was doing project generation? CocoaPods. Have you used CocoaPods? So when you do pod install, what happens? They create a workspace, they create a project, they bring everything together, and it works. So they generate that project. We take the same idea and we apply it to this. So we started. This can be long, so I'll try to. So we started thinking, okay, so what is the first thing that we need to do? So I think the package.swift is kind of cool. People like to write Swift, so people don't like YAML, so design decision that I think was a good idea. Second, it was super annoying, everything related to dependencies. So in Xcode, you end up adding these build phases, and then you kind of construct the graph through those build phases. So what we did in Tuist is we made that super natural to express. So you say, I have a target that depends on this one, and this target depends on this other one. This one depends on an XC framework, and the XC framework depends on another XC framework. And suddenly, everything that is required to make that graph happen in terms of build settings and build phases are all done for you. So you don't have to figure out if you need to. A lot of people come to Tuist and they ask, can I select or say if my framework needs to be embedded or not? And our answer is always, you shouldn't have to be doing that. We do that for you. So if something needs to be embedded, we do that for you. If you do something that the graph, you add something to the graph that is incompatible, we just fail. We don't allow you to do that. What Xcode does is they allow things to be wrong, and then they delegate that to the build system. How many times have you, like compiled the app, gone through the whole thing, eventually you upload the thing to Apple, and Apple rejects the thing when you release the app? Why don't they do that earlier? So we took that input that you give us, the definition of the project, we look at it, we validate it, we fail if we think it's not going to compile. If everything is fine, we continue, and then you get the project. The definition is very simple. It uses the same, it uses Swift, it uses the same concepts as Xcode, and you enjoy that. So we have this foundation, and we said, okay, so people like it, you can describe a very complex project with it, but what if we take that generation phase, and then we use it as an opportunity for optimizing it? Then we did the whole optimization cache and all of that. Alongside, people were using it, and we were working on this in our spare time. So I don't know if you work on open source, but the phases are usually the no one uses me, and that can go to no one uses me, and it dies. I lose motivation. This was no one uses me, there's the first user, oh my god, it's a big company, then this other company, then more people, and then you start evolving the community, and you kind of have the time for that. You can manage the whole thing until eventually you can't. It's like you have to invest so much time for issues, PRs, community, organizing a trip to Korea, all sorts of things. That takes a lot of time. So at some point we said, we need to do something here. So we explored the options, and the one that we thought it was the most sensible for Tuist was something similar to, composable architecture, point free. So they have open source work, which is their packages, and they have their training that they offer. People pay for the training, and they use their libraries. So we have the open source, and then we develop our premium feature, which we call Tuist Cloud. So the idea with that is that we are going to bring the financial sustainability so that we can have people working full-time on the project. Because the other things that we explored don't work, and we think it's very important. We want to continue to support people, and if we don't do anything, either the project dies because people burn out, or the project moves very slowly, which I don't think is a good idea, or we are there, and we balance these two, business and open source. And our mantra is always, let's keep giving the community open source tools. So we, as part of Tuist, we build Xcode Proj library for reading, updating, and writing Xcode projects. We build Tuist, and we have a lot of ideas. We're working on a bunch of other open source projects. So Tuist Cloud is closed source. It's an extension, it's a server, and we, as part of developing all these tools, we continue to develop these other open source tools. But we need the money, so that's why we are building Tuist Cloud.
All right, last question, very quick.
Yes. First of all, thank you for your nice presentation. And as you told, there was a project, and there is their framework ABC, and there is a project. And this project is relation with the framework A and B. And framework B implicitly relation with the framework C. But the framework C is unable to see. The project unable to see this relation framework B and the C relation. And one day there is a project. This project there is another project, and this project is the part of another project. And that can your Tuist this tool is auto completion is build and run, and automatically this implicit relation framework B and the C implicit dependency. This will covering this automatic correctness once the project this Tuist tool is running.
Just to make sure that I understood the question, so in this scenario where there is Tuist enforcing explicitness, are you asking if Tuist prevents you from?
If I use this Tuist tool, another project, the old project there was, and this project is a part of another project, and this.
Could you get the microphone a bit closer?
Oh, okay.
Yeah.
For now, there is a project, and there is their framework A, B, C.
Yeah.
A and B is related with to the this project. And framework B implicit dependency framework C.
Yep.
But project unable to see framework B and the C relations, dependency relation, unable to see. This project, there is another project, and this project part of the another U project. There is no there's wide relation between the ABC, never know the project, but a part of another project. And and after the build run, there was might be something wrong. This Tuist tool, the motor correction, it was used.
Yeah, if you use the tool like scenarios like that, we don't allow them, we discourage them. So we configure the project in a way that if you try to do something like that and it's not explicitly defined, it fails. It fails when you try to build.
If I click the fake, but let's see if I running this tool, this auto correction, figuring out what the relation between framework.
We cannot do, so the only thing that we can do is to fail the compilation, or we cannot tell you, hey, don't try to do that, and instead you should be defining the dependency on this file. Like, we cannot give the developers like actionable steps. He has failed, and then when it says framework not found, you have to know that the dependency is missing. You need to define it. Ideally, Xcode will give us an API for presenting these error messages that are more actionable, but we don't have that, so the only thing that we can do is to fail.
All right, thank you very much. Big round of applause.